Hi, we were going to continue with the rough contouring on the base body. So the base body that we are talking about is the main rectangular shape of this base with the 5 mm chamfer. We are going to use T2, and T2 is the inserted carbide end mill with the cutter diameter of 25 mm, and the number of flutes is 2. So this is the cutter insert size and flute length and the working length. So now let's move on to the master cam. Before that, let's invisible the toolpath. So before we continue, we have to check the step file here whether it is able for us to conduct the contour milling. Contour milling is a 2D operations, and it is best supported by the 2D chains. So in this particular step file, okay, we are talking about the 2D chain. For this case, if we are changing to the top view, so this is the 2D profile that we are talking about, where it is a rectangular shape including the chamfer. But if I move my cursor over, you can clearly see that this area, this one and this one are separated from each other. So if I to continue this one as a 2D chain, in fact this is not going to be works, okay, because if I change to the front view, you can clearly see here is having a step. So for a proper 2D chain, it should be fall in the same plane, where this particular profile and this profile should be fall as same as the top surface. Okay, so to solve this problem, we will have to create a 2D profile by using the function called Silhouette boundary. So this is similar as what we have done in the turning, which is the turn profile, where we are going to copy the boundary for the 3D model. So to do this, let's go to level and create a new level 11. Okay, in this case, I would like to call this as boundary. Okay, so make sure this is activated as boundary. Okay, now you can go to the home and double check whether the color that you are using is something that can be recognized. So I prefer to use green. Then you go to wireframe. So click on the Silhouette boundary, and now just simply click on any surface of this 3D model and click End Selection. So for these definitions, usually we will fix at the tolerance default 0.02, and the filter is also 0.02. So then click OK. Okay, what you notice here, you can see the profile is being copied, okay, to the top of the surface. So if I invisible the solid at this moment, you can see this 2D chain is fall at one plane, and the same plane, which is the top surface. So with this, I'm able to continue with my toolpath contour. Okay, so go to the toolpath, and we were going to start off with the contouring. So click on the contour, and by default in milling, the chain is set as loop. Okay, so this is a closed loop chain. Okay, so just simply move your cursor to select how do you want your cutter to move. Okay, so in this case, if I look at this rectangular shape, okay, ignore the 4 circles here. So I will be required my cutter to move along this rectangular shape. So when I'm moving, you must make sure the cutter directions also. So if you remember, we did cover the G41 and G42. Okay, so for this case, we will like our cutter to move from the right to the left. Okay, so how do you know which one is left, which one is right? So simply just imagine that you are standing in front of the machine, okay, which is this one. Okay, we are standing here and look into here. So this is the right and this is the left. Okay, so if I were to command my cutter to move from the right to the left, I will have to do the first click, which is at the right side. Okay, so I will choose from here. Reason is I will prefer that when the cutter first cut, I'm able to see the cutter in front of the machine. So instead of clicking here or clicking behind or clicking here, I will choose and whenever it's possible, I will choose the front. So in this case, I decided to choose here and do a click. So when you click, you can see this arrow. Okay, you can see, you can zoom in. This arrow is a green arrow. Okay, there is only one arrow. Okay, why is only one? Because the arrow, the cutter will start and end at the same point. So that's why, most importantly, you must check the direction of the arrow is from the right to the left. Okay, so once you have confirmed with this, you can click OK. And same thing, we come to this again. Go to the tool. Okay, we are going to create our T2. Okay, so T2 is diameter 25 end mill. So right click, create 2. So flat end mill, then click next. So cutting diameter is 25, so just click type 25. And for the rest of the value, I will just make it as a default. Okay, and just one additional information for this flat end mill. And since it's actually inserted carbide end mill, so it is also having a 2-nose radius at the cutting edge here. So in this case, to make it more realistic, I will make it as a corner radius. So define this radius as 0.8. Okay, we still remember when we're covering our turning, so we put 0.8 for the roughing operation. Okay, so now we can move on to the next, where the tool number is number 2. Okay, and next you have to define the number of floats, which is 2. Okay, and the material is carbide. So once you have the number of float and the material, you can hit on this button, calculate. So this is the value that you have achieved after the calculated. Okay, now you move on to the next one, which is to define the coolant on flat. Then click OK. And for the name, we will fix at 25. Now it becomes bull nose end mill. Okay, bull nose is because where we have defined the 2-nose radius, so that's why it becomes bull nose. Okay, then for the rough Z step, okay, so in this case, I will put in as a 12%. Okay, so this one is based on the calculator. Okay, this is a 12%. Then click Finish. So if I click on 2, you should see that the feed rate and the spindle speed is according to what you have just defined in your new tool. Okay, now we can move on to the next one, which is the cut parameter. So the first thing that I'll talk about is actually the compensation type. So in this case is the computer. Okay, if I click on the drop down, there is also control, where, and etc. So in our syllabus, we are covering the first two, which is computer and control. Okay, so for computer, it is generally the two path, okay, that is taking into the considerations of the cutter diameter. So for computer, it's very simple. It is just relied on the CAM program, where it will define the fixed positions of how the cutter going to move. Okay, another word is we cannot do any control when we are doing the actual machining. So everything is already been fixed by the CAM program. Okay, and for the compensation direction, this is where we're coming in as a G41, 42, move from the right to the left, from the left to the right. So in this case, it's the left. So I would just want to share with you, for this particular left is also important in the sense that it's tied to the directions of the chain also. So just now, if you remember, we are clicking at this direction where the cutter will move from the right to the left. So this direction must be consistent with the direction here. Okay, if these two directions are not consistent, your cutter might not be able to move according to what you want. Okay, right, so next is about the stock to leave on wall. Clearly mentioned this is a roughing, so I will leave some material for my finishing and I leave 0.2. Okay, so we will fix 0.2 mm extra. And for the floor, I don't need to do anything because I usually will cut to size 0. Okay, for the depth cut, okay, so the thickness of this workpiece is 16. I'm going to cut down to 16. So if I cut straight away to 16 by using this inserted carbide end mill, okay, it might not be works. So to make it more efficient, we will divide into several passes. So to do this, you activate the depth cut and maximum rough step is 3 mm. So remember just now we key in the rough Z step 12%. Yeah, this is where it's coming in as 3 mm. So we don't need to change anything here, just leave it at 3 mm. Okay, and the finish cut, you can put 0 because we will not conduct any finishing here. So that's why just leave 0. And of course, keep 2 down. You have to check this. Is because every time when the cutter is moving in the rectangular directions, it will go back to the beginning of this point. Okay, when it's meet this point and you need to continue with the next pass, so the cutter will no need to be all the way go up to the clearance again, then come back. Then to make this more efficient, you can from this position go down to another 3 mm. So that is called keep 2 down. Okay, so let in, let out. Okay, it is important message and important actions that you need to consider, especially when you are doing the contouring. So for this case, we want to have a smooth let in and a smooth let out of the work for the cutter from the workpiece. So to do this, usually we will fix this as perpendicular. Okay, and the default is the length is 100%, which is 25 mm diameter, right? The arc is 100% 25 mm diameter. Okay, and this entry we will usually fix same as the exit. So to do this, you can just simply hit on this button, copy to the right. So all this will be symmetry. Okay, so I will explain later what is perpendicular and what is the effect when you are doing the let in, let out. Okay, then now you go to the linking parameter. So just now we also do it on the face mill. Clearance is 50 absolute, so we mix it quite a standard way. And retract, we will uncheck this. Fit plane, we will make it as 5 mm incremental. Okay, so these two values are quite standard. But now problem is come to what is the top of stock and depth. So if you go back to the dimensions of this part, okay, so this is actually 4 plus 12. The thickness is 16. So theoretically, okay, I need to cut the workpiece down 16. Okay, but technically, okay, if we cut only to exactly to 16, I will have an issue because I might have a remaining material at the bottom of the surface. Okay, because due to the two nose radius of the end mill. So to resolve this issue, okay, I will prefer to cut further down to 1 mm. So instead of cutting 16, I will cut 17. So come back to here. So for the top of stock, okay, since I already removed the facing, now everything I will cut will be start from 0. So very clear, the top of stock is 0 now. Okay, then I will cut down to the depth of 17. So first the cutting is negative, so I must put in negative 17. And don't forget, this is absolute. Okay, so then click OK. So this is how the cutter going to look like, okay, when it's successfully generated. So if you want to see clearer, you can go back and visible the solid. Okay, so to validate these two paths, click on the backplot, and I would like to move to the top view first so that you can see how is the cutter being moved. So then I invisible the cutting holder. So all this you can control. Okay, and now I move the cutter in step by step into this horizontal direction. This is called length. Then it will let in the arc form. So this is the arc. Okay, so this whole motion, to be precise, this is actually a perpendicular motion. Okay, perpendicular motion means that from this starting point, I move in perpendicular to the first profile. So that is called perpendicular. Because of I'm activating the length and the arc. So end up, it will give me this profile. Okay, then it will continue to cut the entire rectangular shape and come back to the same starting point. Then what is the cutter going to do is will be let out smoothly in the arc form and go to the beginning point as well. Then from here, it will go down to 3 mm and continue the movement. Okay, so if I go to the front view, you can see the cutter is moving down. Okay, so it's moving down when it's come to the same point. Right, so this is the different passes. The last cut. Okay, so if the cutter is continue to cut until the last pass. Okay, so this is the last pass. How do I know? You can see the Z here is -17. So this is the depth that I have defined. So if I were to say the last cut here, okay, let me find, okay, yeah, this is what I'm trying to say, where if I continue to cut to 17, I will be able to escape these two nose radius. Okay, so when I'm doing my second side facing, when I remove my material, this extra curve will be removed by the second side facing. But if I were to stop at 16, okay, you can imagine that this extra material will be stick to the original parts. Okay, so that is the reason why we add in extra 1 mm. So now I change back to the isometric view and I go to the verified operation. Okay, so where you are able to see the 3D how it is being cut. So select the two path operations, then I go to here. Alright, so now I just simply hit the play button. Okay, you can see that the part is successfully being machined accordingly. Okay, so I think for CNC milling, it is very important for you to come to this simulations, or even to be exact, is a verified operation, in order to know whether the cutter has been removed the material successfully or not. Because purely just rely on the lines here might not be able to tell. Okay, so once you have done, remember to save the file. Okay, now we can move on to the next operations, which is the rough contour for these two steps.